Remember, continuous on AB, and alpha is monotonic. Monotonic. Alpha. Earlier we had alpha dash exist, but now only alpha is monotonic. No information about alpha dash. That means alpha may not be differentiable. If alpha is differentiable, only this formula. Suppose it is not differentiable, simply monotonic, that is either increasing or decreasing. F is continuous, so F is Riemann integrable. Earlier we had alpha dash Riemann integrable. So then how to do it? Then integral f d alpha is given by a to b is given by fx f of b alpha b minus f of a alpha a minus a to b alpha df. What is alpha df? Follow previous mode, previous formula. Alpha df means alpha and f roles got interchanged. Where alpha df means, apply the formula. Alpha x, alpha means alpha x, d alpha means f dash x dx. Alpha x, differentiate previous theorem. If it is f d alpha, what did you do? Fx alpha dash x. Instead of alpha, you are having f. Instead of f, you are having alpha. So first function as it is, derivative of second function. So this is f dash x. This is the required formula. This is nothing but actually, this is what you call it integration by parts. Integration by parts is nothing but this formula. So fb alpha b minus f of a alpha a minus first function into derivative of the first function into integral of the second function, derivative of first function into integral of the second function. So like that, you can apply. This is nothing but integration by parts formula. Like when to apply this? If f is differentiable, apply this. If alpha is differentiable, apply that. For example, I'll do one question, one interesting question. So you feel so happy for finding such questions. Evaluate 0 to x square d box x minus x. Look at that question form. Terrible, but very simple. Let us see how to do it. So this is nothing but, this is not differentiable. Earlier you had box x dx square, where x square is differentiable. So you have applied first theorem. Here this is your alpha, this is your f d alpha. But this is not differentiable. Derivative of box x does not exist. Your a is 0. B is 2. Fx is x square. Alpha x. Box x minus. What to do? What is integral a to b? F d alpha. If d is not, alpha is not differentiable. F b alpha b minus f a alpha a. Previous formula. Minus a to b alpha df. Is the formula. Here f is differentiable, alpha is not differentiable, f dash x exists. So what is alpha df means? You can also remember the formula like this. F of a alpha minus a to b f dash x alpha x d. You can remember this as the formula every time. A to b f d alpha. Whenever f is differentiable, apply this. So let us calculate f of b alpha b f of a alpha. So f of b is f of 2 square 4. F of a, f of 1, f of 0, sorry. Alpha b, that is alpha for 2. box 2 minus 2. Box 2 is 2 only. Alpha of A, alpha 0, box 0, minus 0, minus 0. Box 0 is 0. So there is no contribution here, no contribution. 0, 0. Let us see. F dash x. What is f dash x? Fx is x square. Alpha x is box x minus f dash x, 2x. Use this form. So substituting in 1. Integral 0 to 2. This is x square d box x minus x. This is 0, this is 0. 0 to 2. F dash x, 2x. Alpha x, box x minus. This we have to simplify. How to simplify this? Take this inside. So this will be equal to 0 to 2. X box x. You can multiply inside. Minus 2. X into x, x square. X square. Take it. This let us do separate. This can be. Amma?
Minus.
Chepama?
Minus 2 is
minus. Yeah. Plus. Minus. 0 to 1. X box. Break it at integer. 1 to 2 x box. Plus 2 x cubed. Ordinary integration. For this, box x 0 to 1. What is box x between 0 to 1? Box x, rough one. Box x between 0 to 1. Greater than or equal to 0, less than. Easy. Box x between 1 to 2. Substitute in this. 0 to 1. 0. 1 to 2. 1 to plus 2 into 8. Minus 2. X means x square. Plus 60. This is minus 2 square. 4 minus 3 plus 6. 7 by. Okay, this is the required integral form. So this is the required integral of that. So we can calculate integral like this also. This is equal to 7. So if this is here, it's square, no? So suppose this is differentiable, then use first formula. If this is not differentiable, this is differentiable, then use second formula. Okay? This is one of the best applications of Riemann Sutler's extended concept. So there are so many theorems. Theorems, I'm not at all touching theorems. I'm doing pakka in the examination part. So with this, what are all the models I want to cover under Riemann integration? I have covered. There are many things, but I'm not interested because we are doing Riemann integration. Ordinary integration, you have done all. Now, I have some interesting questions I have collected. So I'll try to work out from the previous paper some interesting questions. With this, the topic is over, but I want to do previous papers. That would be interesting. And you feel so happy for that. Then the concept, previous papers questions will be very interesting for you, particularly as students, because we want to know where is the application. Everything appears to be easy in the classroom, but in the examination hall, everything appears to be tough. So this gap should reduce. So you have some knowledge. Is it not? But you should be able to correlate that to the thing which is given in the paper. I'll try to work out that. Let us go for this. I feel so happy working out the previous papers questions or whatever that are. Yes. Is the screen visible?
Okay,
What happened to that? Equal to sin x. L is how to do this? Let us. L is this. Another interesting question. N is f of 1 by n. That is f x is sin x. So sin 1 by n, sin 2 by n, sin k by n. F of 0 is sin 0. I have just substituted. F of 1 by n is sin 1 by n, 2 by n is sin 2 by n, k by n. So, the idea was the child will be through. So, sin 1 by n into n sin 2 by n sin k by n. This is 0 anyway. 0 into anything is 0. So, simplify. How to go from here? Any one of you? Did you get the idea? This is limit n tending to infinity. Don't mistake this as the Riemann's second formula. Generally, students will be confusing. You write it as 1 by n. For Riemann's second formula, you should have outside 1 by n. You are having n. So you cannot apply this. So take sin 2 by n by 1 by n. And so on. Limit sin k by n by 1. So this is 1. Limit n goes to infinity means 1 by n will go to 0. This is like theta. Sin theta by theta as theta goes to 0. So I can write 1 by n goes to 0. As n tends to infinity, 1 by n will go to 0. This is like theta. Limit theta going to 0, sin theta by theta 1. This is limit theta going to 0, sin a theta by theta. That is a. Because we have standard formula. What is the standard formula? How did we get standard formula? Using L'Hospital rule. Limit theta going to 0. You can apply L'Hospital and get this. Sin a theta by theta is a. So instead of theta, we are having 1 by n. Here 2 by n by 1 by n. A is 2, A is k, and so on. This is nothing but a summation formula. K into k plus 1 by summation k. So this is the answer. That's it. I feel so happy by looking at this.
Already చేసామని ప్రాబ్లమ్ ఆల్రెడీ చేసాము ప్రాబ్లమ్
చేసామా? ఓకే ఓకే, నాకు గుర్తులేదు చేసినట్టు. So anyway, this is the interesting question. So next one more question. It should be